This is AP Calculus' AB's Worksheet 11-2 Solutions for Area Between Two Curves. The general idea here is we just need to make sure that we have the left and right bounds, and we just do top minus bottom. So the left bound in this first one is 0, right bound is 1. That's actually kind of easy. You can see in future problems we don't know what the right bound is, but in this one it's easy. We say, okay, the area of that shaded region is going to be integral between 0 and 1. We just need to do top minus bottom. So the top is clearly the f, the bottom is clearly g, so we just say f minus g. And if I'm being super formal about it, I can say f of x minus g of x, and all of that thing multiplied by dx. I could have just said f minus g and called it a day, but I like being nice and formal about it. All right, so from here, I can go ahead and type this in. How would you type this in as fast as possible? I don't want to go to the y equal to button because I just need to enter them once. I'm just going to do math 9 and integral between 0 and 1. And then I'm going to type in my equations, and I'm going to put parentheses around everything. So start the parentheses around the first function, which is f of x, which is 2x times, I'm going to start some new parentheses for this next function, 1 minus x, and then I'm going to close those parentheses. Okay, that was the entire function, so I'm going to close those parentheses around the entire function, and I'm going to subtract the next function. So I'm going to start parentheses for the next function, and I'm going to say it's going to be 3 times, start parentheses, x minus 1, end parentheses, times, start my next parentheses. I don't really need parentheses there, it's just square root of x, so I'm going to hit delete here. It's just times the square root of x, which is second x squared, square root of x. Okay, that was the entire function, so I'm going to end the parentheses here. And I have the subtraction already done, so I can just hit enter. And I get 1.133. Excellent. And I'm going to go ahead and bring my worksheet key from last year up so I can make sure that I'm getting these all correct. All right, next one. Number 2. Find the area of R. Well, it's going to be top minus bottom. We just don't know the bounds in this case. So in this case, I do want to graph these. I'm going to come into my y equal to, and we'll graph these things. So I'm going to say f, I'm going to put in my y1. So I'm going to make a note to myself, this is my y1. I'm going to put the note, this is going to be my y2. So, and just in case I get them backwards. It doesn't really matter if I get them backwards. You just get a negative answer. 1 plus sine of 2x. And then g of x is going to be e to the power of x over 2. X over 2. Cool. We got our graph. What do we want to guess for the window? For the window, let's do an x min of 0. Makes most sense because I'm just looking at the graph. It doesn't look like it goes this direction. My x max, 4 seems fine. And then I'm going to hit a zoom 0 on this one. I'm not going to worry about my y min or max. I'm going to hit zoom 0. All right, that's a little bit too far. I really just want my x max to be about 1.5. So I come back here to my window and change my x max to about 1.5, and then zoom 0 this thing. It's going to be much closer to what I'm looking for. Cool. So I can see what's going on here. So I'm looking for the intersection of the red and blue graph. So I'm going to hit second trace to do a calculation of the intersection. So it's going to be 5, and my left bound here is going to be 1. My right bound is 1.4. I think I have a different prompt than you guys. Whatever the prompt says, type in what the prompt says. I got this value here, which is going to be 1.136 if I'm rounding correctly, which means really what I have here, let me be super formal about this. I'm looking for the x coordinate, and that x coordinate, the x coordinate is 1.136 down here. That looks a little bit better. So my bound, again, is just going to be the integral of the left, which is 0, all the way to that intersection, which is 1.136, of top, which is very clearly f of x, minus your bottom, which is g of x, and then all of that stuff multiplied by dx. I don't know if I've talked about this, but I'll talk about it in this video really quickly. Dx needs to be multiplied by everything. So if you didn't have the parentheses and just had g of x dx, you'd only be multiplying these two, and you forgot the d of x on the f of x term. It doesn't matter in any of AP Calculus. I don't think this ever will take off a point. So I just like being formal. So from this, I'm just going to type it in. Oop, I meant to do second mode to get out of this. I'm going to type in math 9, integral between 0 and 1.136, and f of x is always my y1, so I'll say alpha trace y1 minus alpha trace y2, and hit enter. So what do we get here? We're going to get 0.429, and box it. All right, next one, number 3. We got 2 things to do. Try and find the area of R and S. Okay, so we need to find where does that x coordinate happen. That's a little bit off, so let's go ahead and put you right where you belong. And where does this x coordinate happen? So we need to graph these things. So let's plug these into our calculator. Our y equal button. Let's clear these functions out and put the f of x is going to be my y1. I don't think I need to write that on any of them. They're always going to be in the order that they're presented. So it's going to be 1/4 plus sine of pi x. Pi x. So far, so good. Okay, g of x is going to be 4 to the power of negative, oh, not cosine, 4 to the power of negative x. I just hit delete to get rid of that. 4 to the power of negative x. Excellent. What do I think my bounds are going to be? Window, well, x min is about 0. X max, let's change it to a 5 just to see what's going on. I'm going to hit zoom 0. What's going on? Multiple syntax error. What's going on with my syntax error? Oh, there's a plus up here randomly. I don't know what happened here. Let's get rid of that plus. So delete. Let's graph this thing. It looks like this is the wrong graph. What did I enter wrong? 1/4. Oh, plus needs to go right here. Plus sine of pi x. Okay, does that look good? That looks correct. Okay, so it looks like this is happening up to about 1.1-ish. So I'm just going to make my window to about 1.2, 1.3 is fine. 1.3, and I'm going to hit zoom 0. That should be pretty nice now. Nice, okay. So from here, I can find those intersections. So I'm going to hit second trace to do a calculation. I'm going to hit 5 for an intersect. My left bound is going to be 0. My right bound is going to be 0.5. And my intersection for that first one that I found is going to be 0.178. And then this right bound, I'm going to do the same thing again. Second trace to do a calculation. I'm going to hit 5 for intersect. Follow the prompts. For me, it's asking for the left bound, so I'm going to say 0.5. My right bound, 1.5. And my intersection is exactly 1. So if it's 1, I'm going to say 1.000 to make sure that everyone knows it is rounded correctly. All right, so let's do the bounds. So R, I need to figure out which one is top and which one is bottom. And they're not labeled in this one. Which one is sine? Which one is 4 to the power of negative x? Well, my graph in the calculator makes it kind of clear that blue is the sine wave, which means this one is a sine wave. This one's going woo, right? So this one's going to be my f of x. So I'll label this one f of x. This bottom one is going to be my g of x, which is backwards, right? G is on the top up here and f is on the bottom down here. So in the first one, it's going to be g is on the top, f is on the bottom. It'll be g minus f. So R is going to be the integral from 0 to that first intersection of 0.178 of, again, g is on the top, so I'm going to say g of x minus f of x. Technically, all of that stuff is dx'd. And type this in. So second mode to get out of here. It's going to be math 9 from 0 to 0.178 of my, it's going to be 2 minus 1. So it's going to be alpha trace y2 minus alpha trace y1. And I get really 0.0, it's so small, 0.065. Okay. Find the area of S. Again, this is going to be the bound from 0.178 to 1.000. And now the bounds have been flipped, so it's f of x minus g of x. F of x is on the top. All this stuff dx'd. So I'm going to hit math 9 from 0.178 to 1. And this is going to be now my alpha trace y. Okay. I sometimes get the question, like, what happens if these are flipped? I've already said, like, it makes it negative. Let's go ahead and say I've got it backwards. Let's, instead of saying y1 minus y2, what if I go 2 first, right? Let's do y2 first. I'm purposely doing it wrong. y2 minus alpha trace y1. And, oh no, I get a negative answer. Just make it positive and we're done, right? This is going to be 0.410. Just make it positive because you knew what it was supposed to be doing. 0.410. Nice. All right, moving on to question number 4. Again, every single problem on here is going to have a calculator, so I'm going to leave that up. All right, so we have y equals 6. So this is the equation. Y is equal to 6 is up here. And y equals 2 root x. So this equation is 2 square root of x. And they meet at 9,6. Okay, find the area of R. Oh, that's pretty straightforward, right? Oh, it isn't? No, it is. Okay, it is straightforward. So it's going to be, the bound is going to be between 0 and, what was it, 9 or was it 6? It's always to the x-coordinate 6. So these x-coordinates give you the bounds. So 0, what was the bound? 9. 0 to 9, and then the top function in this case is this function 6. Top is 6. Minus the bottom, which is 2 square root of x. Technically, all of that stuff, dx, right? So this is going to be math 9. I don't even need to do any graphing. 0 to 9 of 6 minus 2 square root, which is second x squared, square root of x. Done. You get exactly 18. This is really with a calculator? That feels weird. That was too easy, and this can be done without a calculator. I'm changing this. In the future years, this is going to be no calculator. This can be done without a calculator. So how would you do this without a calculator? Yes, the answer is 18, but you would do it this way. You can say this is the integral from 0 to 9 of 6, integral from 0 to 9 of 6. I'm going to be informal about this, minus the integral from 0 to 9 of 2 square root of x. And I'm going to change the square root of x into x to the power of 1/2. So this first integral is kind of nice. This integral right here, whenever you have the integral of a constant, remember our trick, it's going to be that same constant times the bound subtracted, 9 minus 0, which is really just 6 times 9, which is 54. So we're kind of done with that one. It's just 54. This is the one where we actually need a little bit of calculus. So for this one, I'm going to ignore the first piece. This second piece right here, this x is going to go up to the power. We're going to say this is going to go up to the power of 3/2. I'm going to multiply down by 2/3, but there is already a 2 out front. This 2 and this 2 are the same 2, and I'm getting a little bit too scrunched in there. So let me maybe rewrite that a little bit better. There was the 2 originally times the 2/3 that got multiplied down. So really what I have here, and by the way, we still have an evaluation bar between 0 and 9. Really what we have, and I'm worried about space, but I think we're good, is a 4/3 x to the power of 3/2 evaluation bar between 0 and 9. Let's do the evaluation bar. This is going to be 4/3 times x, which in this case is 9 to the power of 3/2, and then minus 4/3 of x, which is now 0 to the power of 3/2. Okay, anything to the power of, or 0 to anything is always 0, and 0 times anything else is still 0. This whole thing is just 0, so we're going to go 0. I only need to worry about u. If you didn't know, 9 to the power of 3/2 is the same thing as 9 to the power of 1/2 to the power of 3, which is the same thing as the square root of 9 to the power of 3, which is the same thing as 3 to the power of 3, which is the same thing as 27. So what I really have here is 27. I'm going to write this over here. This is equal to 4/3 times 27. And I'm running out of room. 4/3 times 27. Well, watch this. 27 and 3 can cross cancel down to a 9. So U and U cross cancel to a 9, and 9 times 4 is 36. So 36. So what I really have here, let's make sure that we make sense of this. I had this number here. This is 54. This integral is 54, and I just figured out what that integral is. It's 36. So 54 minus 36 is what I'm really asking. Doing 54 minus 36. Let me maybe move this down a little bit, or move this 54 minus 36, and that's negative. Or not, that's negative. It's positive. Positive 18. Excellent. All right. Number 5, we can definitely use a calculator, and I think we probably should use a calculator. Do we need one? I'm still deciding on whether or not we should do. I think everything here. Yeah, I'm switching these up. No calculator on any of these. We can do this without a calculator. These are easy functions. You should know how to do this. And I think maybe in future years I will make the graph smaller so you have more room to do some math. So, again, integral top minus bottom. So this is going to be the integral. The bounds are pretty clearly between 0. It says, oops, didn't mean that. 0 is right here. This x coordinate is 4. It tells you the x coordinate twice. This is between 0 and 4. And then the top, in this case, is the curvy one, which is going to be the square root of x. And then the bottom is the straight one, which is this x over 2. So the top is the square root of x. And this is going to be minus x over 2. I'm going to leave off the dx and not be formal about this because I want to conserve space here. So how would you do this without a calculator? Well, this is going to be the integral of 0 to 4 of the first piece, which is square root of x. I'm going to rewrite that as x to the power of 1/2. And I'm going to, I'm going to do this work in a little bit. And I'm going to subtract the integral from 0 to 4 of that x over 2. Okay, so how do I do this first piece? So I'm just working on the integral of x to the power of 1/2. That's going to be equal to, that's going to be x to the power of 3/2, and then multiply down by 2/3. And that's going to be evaluation bar between 0 and 4. That's going to be equal to 2/3 of 4 to the power of 3/2. And this is why I'm worried about room on this. Oops, let me do that. I'll work on u over here, maybe. Minus 2/3 of 0 to the power of 3/2. This is all going to be 0. That's a good way to write this so that I'm just going to cross it off and say it's gone. It's 0. And then I need to deal with what is 4 to the power of 3/2. Let's work on that over to the side. 4 to the power of 3/2 is the same thing as 4 to the power of 1/2 to the power of 3, which is the same thing as the square root of 4 to the power of 3, which is the same thing as 2 to the power of 3, which is the same thing as 8. So this whole thing turns into an 8. So this is going to be equal to 2/3 of that 8 that we just found. And 2 times 8 is 16, so this is all going to be 16/3. 16/3. Okay, so we found the first piece of the integral. We found that part right there, 16/3, and now I need to subtract x squared. By the way, if you're just curious what we just found here, what is 16/3? That is what would happen if I ignored this line right here and found the area just underneath this, I guess, this shape. This shape's area is 16/3. And then what I'm going to do is I'm going to subtract this triangle. And guess what? I could do a shortcut for this one. The shortcut, watch. The shortcut for this one is a triangle that is 1, 2, 3, 4. It's 4 units by 2 units. This, if this was a rectangle, it would be 4 by 2, which is 8, but it's half of 8, which is just, I didn't mean to do dash lines here, which is just 4, which means I can do 16/3 minus 4. So this thing, thank you, this thing is just, I can cross it off and say this is just 4. And I can put a note here in case people are wondering. This is by triangle area. Okay, so what I can do now is I can say 16 thirds. I now need to do minus 4. I'll do that over here. I have 16 thirds. I need to subtract 4. Well, 4, I don't have like denominators, so let's make like denominators. And this is going to be the same thing as 16 thirds minus 12 thirds. This is a terrible 3. Let's rewrite you. And that's going to be equal to 4 thirds. Final answer, box it. All right, last problem. Again, I'm going to do this without a calculator. I want to find the area of R. There's a cool trick that you can do on this one. Let's see if I actually want to do that trick. Yes, I do want to do that trick. I'll show you what I mean. So geometrically, I'm going to set up the trick for you guys. Did you know that if I find this area right here, this I'm going to call area 1, it's the same thing as this area right over here, area 2. There's a symmetric relationship, you might say, which means really all I'm going to do is I'm going to find this area right here. That's all I'm going to do. And then I'm going to find that area and I'm going to multiply it times 2. Why am I going to do that? Because this bound of 0 is much, much easier than that bound of whatever you are. It's easy to find. It's going to be 2. But how do I know that it's 2? And that's kind of a good place to start right now. I don't have a calculator for this one. Why do I even have that calculator up there? Use the full room of the screen. What I'm going to do here is I'm going to say, I need to find this, a terrible line, but I can change that later to be in the right spot. You are also in the wrong spot. Okay, right there. You are going to be right there. How do I find that spot right there? And the answer is set them equal to one another. So if I set the equation 4 and x squared equal to each other, you'll find what the x coordinate is. So if I set x squared is equal to 4, square root both sides, and you'll get x is equal to plus or minus square root of 4, which is equal to plus or minus 2, which makes sense. That's the negative 2. Let me do that in pen. That's the negative 2. That's the positive 2. I don't need that negative 2 because, again, I told you my shortcut. I'm only going to pay attention to that right side. So what I'm going to say here is the area is going to be 2 times the integral from 0 to 2 of top minus bottom. Top is 4 minus bottom. Bottom is x squared. Okay, I'm not going to write this whole thing times dx and be formal about it because I need my room to write. So let's get rid of that stuff. Go away. There we go. So this is the same thing as, okay, I'm gonna leave the 2 until the very end, if that's cool with you guys. So I'm gonna remember to multiply by 2 at the very end. For now, the inside, I have the integral from 0 to 2 of 4, and then I need to subtract the integral from 0 to 2 of x squared. Do I need to pay tax person? No, because the derivative of x is just 1. This integral between 0 and 2 of 4 is a shortcut. This thing is the same thing as, bad curly brace, slightly better. This is going to be 4 times subtract the bounds, 2 minus 0. 2 minus 0 is 2, 2 times 4 is 8. This whole thing right here is 8. So we know that this area is 8. We just need to find u. All right, so let's go ahead and do the antiderivative. This is going to be equal to antiderivative. X goes up to the power of not 2, but 3. Divide down by the 3, and evaluation bar between 0 and 2. From here, we get, let's plug in, right? We get 2 cubed over 3 minus 0 cubed over 3. This whole 0 cubed over 3 business needs to go away, and let's say that goes to a 0. And 2 cubed is 8. 8 divided by 3 is 8 divided by 3. So we get 8 divided by 3. So what did we figure out? We know we're doing 8 minus 8 thirds. So let me rewrite this down on here. What we're left with is 8 minus 8 thirds. Once we find that, we're going to multiply it by 2, but for now, let's try to get like denominators. Multiply u by 3 over 3. I'm going to get 24 thirds minus 8 thirds, and that's going to be 16 thirds. But wait, we need to multiply that. Okay, what we just found, just before I go too fast, 16 thirds is this area right here. I'm going to say that is also, therefore, 16 thirds, and our final answer is going to be 16 thirds. That's just one area on the right. Therefore, to get 2 areas, we're going to multiply it times 2, and we get 32 thirds for our final answer. Cool, I hope you learned a few new tricks along the way. That does conclude AP Calculus AB's Worksheet 11-2, Area Between Two Curves. Thanks for watching.